happy evening for all the viewers from ANC team. Now before I start the session, very important key point, as most of the students are aware of, today I am going to discuss a very important topic called as removal and replacement. I am going to discuss a very important topic called as removal and replacement. Now this particular topic, removal and replacement, in fact for all the old students who have attended my class, I took so many varieties of questions in a beautiful topic called as averages. Then followed by averages is a beautiful topic once again called as mixtures, wherein I have taken several varieties of questions covering every variety what is possible in terms of mixtures problems. And the continuation of mixtures, there is a very slight difference between mixtures and another topic, and that another topic is called as alligations. Averages, mixtures and alligations I have taken in detail in my previous YouTube sessions. And I believe that each and every enrolled student of ANC, I believe that they have watched all these videos at their comfortable time, and they have watched it as many times as possible to understand each and every concept in the most beautiful way possible. Now these three topics whatever I have discussed, the next topic in the same domain is nothing but removal and replacement. The next topic in the same domain is nothing but removal and replacement. And this removal and replacement is what I am going to discuss in this today's topic. My sincere request to each and every student who is listening to the class is kindly share this YouTube link to as many people as possible, sir. Kindly share this YouTube link. I will give you the next 1 minute of time. Kindly share this YouTube link to as many people as possible. My also sincere request, one more sincere request is, like the way I have kept the YouTube link as my WhatsApp status, it is just for 1.5 hours. I request you people also to keep it as WhatsApp status, so that every student who is actually struggling to solve an aptitude problem, I am sure that after this session they will start loving aptitude and they will probably make it very beautiful in solving aptitude problem. Kindly share this YouTube link, sir. Before this, as I would always ask in my sessions, kindly check for any technical issues. Is there any issue with audio? Is there any issue with video? Kindly update me right now itself if there are any issues with audio or video. If there are any issues, update me right now itself, sir. Next 1 minute of time, I request each and every student to share this YouTube link with as many students as possible. Kindly comment in the live chat, sir, if there are any audio and video issue. In the next 1.5 minute of time, we will start a very beautiful topic called as removal and replacement. An extremely important topic which actually deserves a lot of attention, and many people are not listening to this class. I don't know what might be the reason. Anyway, let us not worry too much about them. First, my request is people who are present for the class, kindly comment in the live chat if there are any technical issues. If there are no technical issues, at least comment in the live chat saying that there are no technical issues, so that I will understand. I will start the class immediately in the next 1 minute of time. Kindly comment, sir. I am waiting for each and every student to comment. Kindly comment in the live chat. I am still waiting for your comments, sir. If you think that there is no requirement for you to comment anything, I will never ask you again. It's been 3 or 4 times I am asking you to comment in the live chat. My sincere request, please comment in the live chat before I start solving this beautiful topic on removal and replacement. Chalo, sir. Most of the people say that there is no issues. Let me start the class immediately. Let us start a very important topic called as removal and replacement. Very important topic, sir. It is after averages, mixtures and alligations. The next topic, which is a continuation of alligations, averages and mixtures, is nothing. We also take so many questions which were original examination questions as well. Do not miss out the class at any point of a time, because you will understand the importance of this particular topic as I keep on proceeding with my class. Listen to this carefully, sir. Removal and replacement. Now, before I start with removal and replacement, first let me take a very small example for only removal. Forget about replacement, sir. Let us not replace anything at this present moment. Let us not worry about replacements. We will only concentrate on removal part for the next couple of minutes, and then after understanding removal, we will come back to that removal and replacement, and we will see how beautifully we can solve removal and replacement problems. Now see here, sir, I will take a very easy example for your better understanding. Suppose I have a vessel. This is the vessel which I have written on the screen right now. Suppose I have a vessel. Assume that I have an initial volume of 1000 ml inside the vessel, and I will take that this entire 1000 ml is pure milk. That means there is no other liquid present inside the vessel, only pure milk is present. That means there is no adulteration, there is nothing added to the milk, it is completely pure. I have initially 1000 ml of pure milk. So what I will do is, right now I am discussing only a concept called as removal. Let me keep on removing some things, and then let me worry about replacement at the later stage. Now what I will do is, first step, I will take out 100 ml of milk from this vessel. I will take out 100 ml of milk from this vessel. Now again I will take out another 100 ml of milk from this vessel. First I took 100 ml of milk from the vessel. Second step also, again I will take another 100 ml of milk from the vessel. Third step also, I will say that I will take out 100 ml of milk from the vessel. That means out of total 1000 ml, I took 100 ml, I again took 100 ml, for the third time also I took 100 ml of milk. My question for you is, what is the final volume of milk? What is the final volume of milk inside the vessel? What is the final volume of milk inside the vessel? That is my question for you. Now, this is a very easy answer for every student who is listening to the class, because the problem what I have taken is a very easy question. Right? Now see here, sir. It is very simple for you to tell that. Suppose, for example, if I want to find the final volume of milk, initial volume of milk is nothing but 1000 ml. From this 1000 ml, I removed 100 ml initially. Again I am removing 100 ml. Removal is nothing but subtraction, which you are already aware of. Again I am removing 100 ml. That means out of total 1000 ml, I removed 300 ml of milk. So total final volume which is present inside the vessel is, final volume of milk present inside the vessel is, it is 1000 minus 300, which is nothing but 700 ml. Now you might get a doubt, sir, why are you discussing such a very easy question? This happened to be one of the most easiest question, because it is nothing but subtraction, what we have studied in class 1 or class 2. I have studied in subtraction in my first or second standard itself. Why are we more interested in this method? Why are we discussing this particular problem? Just keep on listening to my class, sir. Do not conclude anything for the next few minutes. You will understand everything. I will connect the dot between each and every problem, and I will make sure that some of the difficult tricky questions you will solve it in the most easiest way possible. Now, final volume of milk in this question is 1000 minus 300, which is 700 ml. But this happens to be a very easy question, and therefore the answer also is very easy methodology. You got this answer in one of the most easiest method. Let me call this as method 1, right? Let me call this as method 1. Now, before I go for removal and replacement, I want to teach each and every student a very important and an interesting method. That method is called as method 2. Usually what we call it as ANC way of solving. Anil Nair classes way of solving. Now listen to this carefully, sir. What is this method 2? What is this method 2 I am talking about? A very important key point is present in method 2. Only with this important key point, we will solve some extraordinarily difficult questions in our next 1 hour of our class to make sure that we will understand removal and replacement in the most easiest way possible. What is that key point? This key point says, always work with the parameter. Always work with the parameter which is decreasing. Always work with the parameter which is decreasing. Now, if I take this question, whatever I have written on the screen in my previous screen, let me show it to you right now. Always work with the parameter which is decreasing. Now, first of all, in this particular question, how many parameters are there? There is only one parameter, and that parameter is nothing but milk. And what is the parameter which is taken outside? Which is the parameter which is taken outside? The parameter which is taken outside is nothing but the parameter which is decreasing, right? Because that is coming out of the vessel, so it is decreasing. That means you are taking out milk outside the vessel. That means milk is the parameter which is decreasing. Anyway, in this question, there is only one parameter. So let us not worry about this question as of now. I am talking in general. Whenever there are more than one parameters, always work with the parameter which is decreasing. Now, milk is decreasing in this particular question. So, I am finding the final volume of milk. I am trying to find the final volume of milk. How will you find the final volume of milk? Listen to this carefully, sir. Initial volume is 1000. I am going very slow in my first question, because if you understand method 2 for this question, rest all next 1 hour all the problems will become cakewalk for you, sir. That is the reason I am spending too much of time in explaining this method 2 in a very easy question. Initial volume is 1000. Write it as 1000. 1000 into, now observe carefully. Observe carefully. This is very, very important. Now can I say that initially 1000 ml of pure milk is present. Out of this 1000 ml of pure milk, I am taking out 100 ml of milk outside. I am taking 100 ml of milk outside. That means out of 1000 ml of milk, 100 ml of milk is taken out. That means 100 out of 1000. That is nothing but 1 by 10. 1 by 10 is taken outside. 1 by 10 is taken outside. If I take out 1 by 10 from outside the vessel, what is present inside the vessel? I am talking about what is the final volume of milk inside the vessel. If I take out 1 by 10 outside, what is present inside? Inside present is 9 by 10, because 9 by 10 is nothing but out of total parameter 1, I am removing 1 by 10. 1 minus 1 by 10 is nothing but 9 by 10, or in simple language, 9 by 10 plus 1 by 10 should give you 1. That is nothing but the entire parameter. That means in simple language, I am taking 100 out of 1000. 100 out of 1000 is nothing but 1 by 10. 1 by 10 is taken outside. If I take out 1 by 10, how much is remaining inside the vessel? I am very much interested in knowing how much is present inside the vessel. Remaining 9 by 10 is present. 9 by 10 is nothing but total minus 1 by 10 taken out. That means I will write here as a remaining part 9 by 10. Now, if you observe carefully, if I take out 100, remaining is 900 inside the vessel right now, right? Remaining is 900 inside the vessel. Now, again, same logic I would like to implement, sir. There is no change in the approach. Out of 900 which is present, right now 900 is present. Out of 900 which is present, I will take out 100 ml of milk outside. That means out of 900, 100 is taken out. 100 by 900 is nothing but 1 by 9. 1 by 9 is taken outside. What is present inside? 8 by 9, because 8 by 9 plus 1 by 9 is only 1 only, right? So it is nothing but 1 minus 1 by 9. That means I will write here as remaining present is 8 by 9. Similarly, I would say that at this point of a time, out of 1000, 100 taken outside, 900 remaining. Out of 900, 100 taken outside, 800 remaining. Now tell the same logic, sir, once again. If I use the same logic once again, 800 is present inside the vessel. Out of 800 which is remaining, I will take out 100 ml of milk outside. That means 100 out of 800 is taken out. 1 by 8 is taken outside. If I take 1 by 8, remaining is nothing but 7 by 8, because 7 by 8 plus 1 by 8 is only 8 by 8. 8 by 8 is 1. That means remaining present inside is 7 by 8. 8 cancels. 10 cancels with 1000, 9 cancels. 100 into 7 is nothing but 700. The final volume of milk which is present inside the vessel is how much? It is 700 ml. Yes, I do agree the fact that method 1 is more simpler than method 2 for this particular problem. But again I repeat, it is only for this particular problem. As I move on to removal and replacement, you will understand why method 2 is one of the most easiest method to be implemented, and you will damn sure start implementing method 2 rather than using method 1 in all your problems on removal and replacement. First of all, now see here, suppose if I take out 8 by 9 of mixture outside, if I take out 8 by 9, remaining is 1 by 9, because 8 by 9 plus 1 by 9 is 9 by 9, 9 by 9 is 1. Suppose if I take 7 by 8 outside, remaining is 1 by 8. Suppose if I take 3 by 5 outside, remaining is 2 by 5. I hope you are understanding this logic, because 3 plus which number is 5? That is how I am thinking, sir. Simple. 3 plus which number is 5? 3 plus 2 is 5. 8 plus which number is 9? 8 plus 1 is 9. 7 plus which number is 8? 7 plus 1 is 8. Suppose, tell me the answer for this. If I take 13 and here I will take 10. 10 by 13 I have taken outside. What is remaining inside? It is nothing but 3 by 13, because 10 plus which number is 13? 10 plus 3 is 13. I hope this is very clear for you. Shubham, I will move, sir. I will move forward. I know it, but only thing is that students should be very clear with all these concepts as well before I start moving for removal and replacement. Method 2 should be very clear. Praveen Kumar, do not worry about it. I will explain once again this method 2 in my removal and replacement problems. I will explain it once again, sir. No worries about it. Definitely, for sure, I will explain method 2 once again. In detail I will explain method 2 in my removal and replacement. Now, I personally believe that every student is very clear with only removal. That means if you observe this question, I am only removing something outside. I am not replacing. That means I am not adding back something inside. This particular problem is only removal, because only process what I am doing is taking something outside of the vessel. What if I put inside something? That is nothing but removal and replacement. Now let us start with this very important topic called as removal and replacement. I will not only remove something in this case, but I will also make it as a habit to replace it with some other solution, so that becomes a question on removal and replacement. Everybody please pay complete attention for the next 10 to 15 minutes. Beautiful shortcuts will unfold in the next 10 to 15 minutes. Never seen ways of shortcuts, sir. Listen to this very carefully. Now see here, I will start with my first question in removal and replacement. First of all, let us read the entire question, and then I will again read the question, but not completely at one stretch. Later on, I will read part by part. First, let me read the entire question once. Question says, from a can containing 1000 ml of milk, 100 ml of milk is removed and replaced by 100 ml of water. That is the first statement. Then 100 ml of solution is removed and replaced by 100 ml of water. That is the second statement. Next statement says, again 100 ml of solution is removed and replaced by 100 ml of water. And the final statement says, the question says, what is the final volume of milk and water in the resultant can? What is the final volume of milk and water in the resultant can? Listen to this carefully, sir. Everyone please pay complete attention here. Let me understand the question, and let me also make you people understand the question. Now, there is a vessel, or in general there is a can, right? There is a can. Now, what is that they are saying is, from a can containing 1000 ml milk, that means initial volume of this can is, it is 1000 ml pure milk. Nothing is added. It is completely pure milk inside the vessel initially. 1000 ml of pure milk is present inside the vessel. The statement says 100 ml of milk is removed. I am taking out 100 ml of milk. I am taking out 100 ml of milk outside and replaced by 100 ml of water. I took out 100 ml of milk. I am replacing it. That means I am adding 100 ml of water into the vessel. This is nothing but removal and replacement. I am taking out 100 ml of milk. I am adding 100 ml of water. Now think little logically, sir. Everyone should have this basic minimum understanding or common sense, saying that earlier it was completely pure milk. Now I added some other liquid called as water into the milk. The milk and water are combined together inside the can right now. That means now it is no more pure milk inside the vessel. It is no more pure milk inside the vessel. It is a solution or a mixture which is present inside the vessel right now. It is no more pure milk. It is a solution, combination of two liquids. One is milk, another is water. Or it is a mixture, anything, whatever you want. That means now the mixture of milk and water is present inside the vessel. Read the next statement. Then 100 ml of solution is removed. Yes, I will take out 100 ml of solution outside. I will take out 100 ml of solution outside and replace it by 100 ml of water. I will again add back 100 ml of water. I am replacing it by 100 ml of water. Next, what is the next statement says? Again 100 ml of solution is removed. I will once again take out 100 ml of solution. Beautiful question. Listen to this carefully. I will once again take out 100 ml of solution and replace it by 100 ml of water. I will once again add 100 ml of water into the vessel. This is the operation which I am performing. Your question is, what is the final volume of milk and water in the resultant can? What is the final volume of milk? What is the final volume of water? This is what they are asking you in the question. I believe the question is very, very clear for you people. I believe that the question is very, very clear. 100 ml of milk is taken out initially, added 100 ml of water. Now it is solution. 100 ml of solution is taken out, added 100 ml of water. Again 100 ml of solution is taken out, added 100 ml of water. But please remember, initially it was only pure milk of 1000 ml which was present inside the vessel. Now listen to this carefully, sir. I believe the question is clear. I will solve this question in two methods. Sir, which method should I use? It is completely up to you, but I am damn sure that you will start using method 2, which is ANC methodologies. I think you will understand method 2 better once I start solving two questions. Listen to this carefully. Do not worry about method 2 at this present moment. Now let me create a table. Method 1 is your textbook way of solving, which is little time consuming, but that is still okay with me as long as I can make my students understand. There are two parameters. One is milk, other is water. And let me keep the third column as the total volume present inside the vessel, right? Total volume present inside the vessel or the can. Now, initially 1000 ml of milk is present. No water initially. So, total volume is 1000 ml, right? Total volume is 1000 ml. Now listen carefully, sir. Now, everyone please concentrate and understand it little carefully. What is that they are saying is, initially 1000 ml of milk was present. I am taking out 100 ml of milk outside. I am taking out 100 ml of milk outside. That means 100 out of 1000 is taken outside. 100, I am writing it for the last time probably. 100 out of 1000 is taken outside. That means 1 by 10 is taken outside. If 1 by 10th of the milk is taken outside, how much milk is present inside right now? Milk present inside is remaining 9 by 10, because 1 by 10 plus 9 by 10 is nothing but 1. That means out of 1000, 100 is taken out. 1 by 10 is taken out. Remaining inside is 9 by 10. That means milk is nothing but out of 1000 which was present earlier, now only 9 by 10 of milk is present inside. 1 by 10 was taken outside. Vedant, please do not I do not expect you to answer beta. Please avoid posting the answers in the live chat, which will disturb the flow of the class. Keep your answers with yourself. Validate the answer once the problem is completed. My sincere request for every student. Out of 1000, 1 by 10 is taken out. 9 by 10 is remaining. So 100 So it is 100 into 9. That means 900 milk is present inside right now. I will add, next step says add 100 ml of water. That means I will add 100 ml of water. 900 plus 100. Once again the total volume becomes 1000. Once again the total volume becomes 1000. Now listen to the next statement, sir. See the next statement. Now I have added water into the vessel. Because I have added water into the vessel, it is no more a pure milk right now. It is a solution or a mixture. Now listen carefully. Solution or a mixture means I am taking out 100 ml of solution outside. Solution is nothing but a combination of both milk and water. That means, can I say that now, right now, can I say that how much is present inside right now? How much milk is present inside? 900 ml of milk is present inside right now. And how much water is present? 100 ml of water is present inside right now. Now think logically. 100 ml of solution is taken out. That means I can say that total volume till again now is 1000 itself. Total volume happens to be 1000 right now also. That means 100 out of 1000 is taken out. 100 out of 1000 is taken out. That means 1 by 10 is taken outside once again. Remaining inside is 9 by 10. That means 900 is multiplied by the remaining factor called as 9 by 10. So 0 cancels. 9 into 9 is 81. Followed by one more 0. Now same logic here also. 100 ml of solution is taken out. That means 1 by 10 is taken out. Remaining is 9 by 10. That means 9 by 10 of milk is present. Same thing, 9 by 10 of water is also present. 0 cancels. I can say right now as 10 into 9 as 90. Now step number 3 is completed. Step number 1, 2, 3 are completed. What is step number 4? I am adding 100 ml of water once again. That means the present value of water inside the vessel is 90. I will add another 100 ml of water. So now the present value of water inside is 190. If you want, check it out. 810 plus 190. Again the total volume happens to be 1000 itself. Once again the total volume is 1000, sir. Total volume remains constant unless they change it, right? It is 1000. That means now the total volume is once again 1000. How many steps are completed? 4 steps are absolutely no doubt, without any hesitation, it is completed. Now come to step number 5. Now 1000 ml of solution is present inside the vessel. Now again step number 5 says 100 ml of solution is taken outside. That means 100 out of 1000 is taken out. Same drama, sir. Same drama. No other changes. 100 out of 1000 is taken out. 1 by 10 is taken out. Remaining inside is 9 by 10. That means milk present right now is 810. And present milk is, when I take out 1 by 10, remaining is 9 by 10. So this is 10 cancels. 81 into 9, it is 729. Water at present is 190 and 9 by 10 of water is present inside. So 0 cancels. 19 into 9 is 171. So at this particular point, 5 steps are very, very clear. There are totally 5 steps which are completed. Please come to the last step of this problem. The final step says I want to add 100 ml of water. That means water right now in the vessel is 171. I will add another 100 ml. So final water becomes 271. If you want, check it out. 729 plus 271. That also happens to be 1000 ml of final solution, total solution. That means question says what is the total volume of final volume of milk present? It is 729 ml. What is the final volume of water present? It is 271 ml, which is rightly said by Vedant, which is rightly said by him, sir. Right? Answer for this question is 729 ml milk is present finally. 271 ml water is present finally. But the biggest problem with this method 1 is it is a tabular method. It is a very time consuming method. If we use this method, we will take too much of time in our examination, and A and C will always teach you one thing, saying that anything which will kill your time in your examination, please kill that method in yourself. Please kill that method, sir. I don't want my students to use all these stupid approaches which is given in some textbook and some other YouTube channels. Please throw away all these methods. But why did I teach you this method? I taught you this method for you to realize that this is a time consuming method, and let us switch on to method 2, which is nothing but A and C way of solving. But before I switch on to method 2, kindly comment in the live chat if method 1 is clear, sir. Kindly comment in the live chat. First comment in the live chat if method 1 is clear. After method 1 is clear, I will switch on to method 2. Method 2 is the most easiest method that any person can solve it with respect to removal and replacement problems.